Okay, this is basically we'll go over a couple more problems with the zero product property, and then we'll do a couple of problems with that review of the parabola, the graph, creating the graphs with the parabolas. So we talked about the zero product property, that if we have a product equaling 0, then either one or both of the factors has to equal 0. That allows us to solve higher degree equations. We're going to focus on quadratics, which means we have an x squared as the highest degree. So here are some examples that I've already gone through and done. Remember, our key here was we talked about factor, split, solve. So if we have to solve, this is a quadratic equation because it has x squared. We can't just isolate x because we have these two different x terms which are unlike. So we rewrite it as the product of x minus 5 and x plus 4 has to be equal to 0. Well, the only way this could be true is if x equals 5 or x equals negative 4. And with any equation that we're solving, we can check our answer. So we can go through and plug in 5 into the original expression, plug in negative 4, and show that it does in fact make this expression equal to 0. So example B, it's factored into x plus 1 plus x plus 1. Remember we said that if it was squared, we usually get two answers. Well, this is another example of where that same answer occurs twice. And we can check it if we plug in negative 1. We'll get 1 minus 2, which is negative 1, plus 1 does equal 0. So that answer does make that true. All right, let's do a couple of these from start to finish. So this first one we're going to look at, that's a 10x squared minus 5x minus 30 equals 0. So we want to factor, split, solve. Always look for a GCF first. So I notice that 10, 5, and 30 are all divisible by 5. So I'm going to factor out that 5. So that will leave me with 2x squared minus x minus 6 equals 0. Now this, I'm going to check to see if I can then factor this further. So it's got to be 2x and x. Well, if this is negative and this is negative, then one of these has got to be positive, one's got to be negative. So we'll have to figure out factors of 6 or 6 and 1 or 2 and 3. We're going to use 2 and 3 to get 1 in the middle. So this would give me negative 4 plus 3, which when we add would give us negative 1, and that multiplies to give us negative 6. Notice we also bring down that factor, that GCF of 5. Now we have 3 factors. We set each factor equal to 0. So this is the split part. Now we have 3 equations to solve. Well, the first one, 5 equals 0, no variable term, and that's an untrue statement. That does not give us a solution. All right, we'll subtract 3. We get 2x equals negative 3, divide by 2, and we get the solution of negative 3 halves. Here we'll get x equals 2. And I'm not going to have enough time in this video, but to check these, I would plug each of these back in for x and make sure it makes this original equation true. I want you guys to pause the video and try D. Alright, so if you look at your work for D and compare it to what I have, I did use that x method of factoring that a lot of you like to use. So you multiply 2 times the negative 9 to get negative 18, write down the middle term. So we had to find 2 factors that multiplied to give us negative 18 but added to give us 3, and they were 6 and negative 3. But then, remember, if this has a coefficient, if a is any value other than 1, we have to divide by that ax, and this first one reduces, so it's x over 3, I'm sorry, 3 over x, which was the factor x plus 3. and then the other one doesn't reduce, so that stays as a factor of 2x minus 3. And I always check. See how this would give me 2x squared. Plus 6 and minus 3 would give me a positive 3x. And notice how that multiplies to give us negative 9. Now we split. So that gives us two equations. We solve each one. If squared, we would expect two answers, and we get 3 halves and negative 3 is our answers. All right. The same technique can work if we have something higher in degree than a quadratic. So in this first one, this is a 4th degree, but it's a 4th and a squared. We want to look for a GCF, and we do have one of 2. So I'm going to take that GCF out first. Okay, so that, take out the GCF of 2. Now I want to factor this part. So x to the 4th would be x squared and x squared. And the reason it's not, for example, say x cubed times x is because that middle term is x squared. So now I need factors of 36. It would give me a negative 13. So, and they both have to be negative in order for this product to be positive, but the middle term to be negative. So they would be 9 and 4. Because 9 times 4 is 36. I add negative 9 and negative 4, and I get negative 13. So we check this and see how it would take us back. These are equivalent expressions. And now each of these is also factorable. This will factor into x minus 3, x plus 3. Then this will factor into x minus 2 and x plus 2. So this, remember what we talked about with the highest degree, determines the number of possible answers. So I could have as many as 4 possible answers. I would set each of these equal to 0. 2 equals 0 is not true. This would equal 0 when x equals 3. The next factor would equal 0 when x is negative 3. This one would equal 0 when x is 2. And this factor would equal 0 when x is negative 2. So here's an example of 4th degree, 4 different answers. All right, I want you guys to try F. F. You did have a GCF of 3x, and this is that other part of that factor once we take out that GCF. That itself is also factorable into 2x minus 1 and x plus 4. So now we have 3 factors. Split. Set each factor equal to 0. And we do get the 3 expected answers. X equals 0, 1/2, and negative 4. Okay, the next example requires us to recall and remember what we learned about graphing parabolas. So we had to remember the vertex formula, okay, we have to remember that x-intercepts are the points when y is 0. And then we can also find, I'm going to add y-intercepts. Remember, whenever we find y-intercepts, x is 0. So for this parabola, we know it's a parabola because it's squared. We know it's going to open up because a is positive, a is 1. It's a coefficient of x squared. b is 8. It's a coefficient of x. And c is a constant, which is 12. So the vertex, which is the point where it changes direction, so I take opposite of b, which in this case would be negative 8 over 2 times a, so 2 times 1 is 2. Simplify that ratio and we get negative 4. So the vertex will have an x-coordinate of negative 4. Now we need the y-coordinate. To find that, we evaluate this using negative 4 for x. So we would do the math. Negative 4 squared plus 8 times negative 4, and then add 12. So we're going to get 16 minus 32, which is a negative 16, plus 12 is a negative 4. So that's at vertex. So that means at negative 4, which I'll plot that right here because I'm eventually going to have to graph this. We know this parabola is opening up. That's going to be the lowest point. All right, y-intercepts means that y is 0. X-intercepts means that y is 0. So basically we're looking at this equation. So we need to find x-intercepts by solving this equation, which is what we just did. So we're going to factor split and solve, and we would get x equals negative 6 and x equals negative 2. So those are ordered pairs since we're looking for the graph. So it allows us to make a little bit more accurate of a graph. So now we have more points to plot. And now the y-intercept, that means I put 0 in for x and solve for y. So it's 0 squared plus 8 times 0 plus 12, and it's always going to equal whatever the constant is. So that's, again, is another point, and that would be 0, 12. Now that's kind of going off my graph, so I'll just estimate it up here. Now I have enough information, and I would have that same point, same distance over here, remember, because we have that symmetry line that goes right through the middle of that vertex. But here is the sketch of that parabola. So I want you guys to do example 3. Okay, check your work. This parabola would open down because A is negative, B is negative 6, C is negative 8. So we find the x-coordinate of that vertex by doing opposite of B, which would be 6, over 2 times negative 1, which is negative 2. So we get the x-coordinate of negative 3, plug that back into the original equation, and we get y is 1. X-intercepts are when y is 0, so we have to solve this quadratic equation, factor out the negative 1, and then this factors into x plus 4, x plus 2. Solutions are negative 4 and negative 2, so those would be the following ordered pairs. I also found the y-intercept by making x 0, plot the points, and then we have the parabola. All right, we'll look at some more of this tomorrow in class.